Okay, so we begin this class. Once again, very good day to everybody. This is wireless networks, and in today's class, we'll discuss about the basic concepts of the IEEE 802.11 standard. So this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again, let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students and young researchers. So in this class, we'll discuss about the basic concepts of Wi-Fi. Then we'll discuss about AP, access point. Then we discuss about ESS, briefly, extended service set. The overview of DS, distribution system. The messages exchanged in the connection process. Then we'll discuss about passive scan. The description of the mandatory field of a beacon frame. Then we'll discuss about the difference between active scan and passive scan. We'll also discuss about the SSIDs and BSSIDs, okay, and we'll discuss about authentication, wired equivalent privacy encryption. So then we'll discuss about authentication frame, the association request and association response, and at regular intervals we'll be giving you some short videos to discuss the knowledge in our topics, right? So you know the basic concepts of Wi-Fi. So different IEEE 802.11 standards are used in Wi-Fi, and they will be differing in the operating frequency and data rate. So we'll understand the important components. First of all, stations. So stations will have several devices which are connected to the wireless LAN. So station is a device that contains 802.11 compliant MAC as well as physical interface to the wireless medium. So a station can be laptop or maybe desktop PC, access point or maybe smartphone. So station can be fixed, can be mobile or maybe portable. Okay. So then we'll have access point. So access point is a device that contains a wireless local area network, wireless LAN. Okay. So it has a station functionality, and of course it will be providing access to the distribution services through the wireless medium. So access point, the center point, is a device which allows Wi-Fi clients and of course Wi-Fi enabled routers in order to connect to the wired network. So AP will be connected to the wired router, a switch or maybe a hub through the Ethernet cable and projects the Wi-Fi signal to the defined area. Okay, so the access point will be receiving data by the wired Ethernet and it will be converting to a 2.4 or maybe a 5 gigahertz wireless signal. It will be communicating with the nearby wireless clients. So maybe in the Wi-Fi network, so the wireless client will be communicating to all other wireless client through the access point. Okay. So client. So it's a device which connects to a Wi-Fi or maybe wireless network. So any device that transmits and of course receives the Wi-Fi signals, maybe like laptop or maybe a printer or maybe smartphone, it's a Wi-Fi client. Okay. Then we have BSS, basic service set. So a group of stations that are successfully synchronized for the 802.11 communications. So basic service set will be containing one access point and one or more client stations. So in basic service set, the stations have layer 2 connection with the access point that are known to be associated. Okay. Then we have BSSID, basic service set identifier. So all basic service sets we are going to identify by a 48-bit or maybe 6 octet MAC address called as the basic service set identifier. Okay. So BSSID address is the layer 2 identifier of each of the individual basic service set. So most often the BSSID address is the MAC address of the access point. Okay. Then we have DS, distribution system. So a system that interconnects a set of basic service set and integrated local area network to create a extended service set. Okay, ESS. So it is going to extend the wireless network coverage. So that is the basic functionality of the distribution system. Then we have ESS, extended service set. So in extended service set, one or more basic service sets are connected. So an extended service set is a collection of multiple access point and their associated clients. Okay. Then we have IBSS. Okay, Independent Basic Service Set. So IBSS consists only of client stations that will be doing peer-to-peer, end-to-end communications. So Independent Basic Service Set, it's a self-contained network that does not have access point. Okay, access point yoke. Okay. Then we have SSID or maybe ESSID. So it's a service set identifier or maybe extended service set identifier. So the logical network name of the extended service set, you can call it as the service set identifier or SSID. So here you allow stations to connect to the desired network when the multiple independent networks operate in the same physical area. Then you have roaming. So it's a process of client moving from one access point to another access point. For example, you are in Samarkand, maybe you go to Tashkent, roaming stage. So within the same extended service set without losing the connection. Okay, so that is roaming. So here we'll have the overview of distribution system. The distribution system. Okay, so you'll have the SSIDs, NXP, AP. Okay, so station, it will be communicating to the AP1 through the distribution system. Then this will be communicating with the AP2. So here we'll be having the device roaming. Okay, BSSID here, BSSID also here. So this will be connecting to the station, your laptop. Okay, right. So in 802.11 standards, the connection procedure includes 3 major steps that can be performed to make the device part of the Wi-Fi network and communicate in the network. So maybe with a client, here you see, okay, to the access point, scanning first of all is done. Then request, authentication request is there. Then in return you get the response. Then association request. Then association response. Then only data transfer takes place. Okay, right. So the 3 steps are nothing but device discovery. First of all, you on means then you discover the device. Okay, so that is scanning. So immediately when you switch on the Wi-Fi, scanning. Okay, then device authentication. Sometimes scanning okay, but authentication failure will happen. So you have to check. Okay, so you are going to check the compatibility capability before the connection and then finally establish the connection. So we'll go for the messages exchange in the connection process. So we'll have the probe request, acknowledgement, probe response, acknowledgement, authentication, acknowledgement, authentication. Again it will go on association and acknowledgement. So that it will go on scanning, authentication and association. First one, scanning. So in order to join any network, first the client or maybe station has to find its network. So in the wire network, just plug the cable or maybe jack, that will find the network. In the wireless world, you have to identify whether it is compatible network or not before joining the process can begin. So this identification process, you can call it as a scanning. So several parameters are needed in the scanning process. Basic service set type, basic service set identifier, channel list, scan type, minimum channel time and maximum channel time. Okay, so suppose let us take, we establish some connection. Maybe after 5 minutes you are not connecting, then it will close down. Immediately it will switch off. Okay, so the parameters are set as default depending on the manufacturer Wi-Fi driver, but it can be modified by the user, which means that if the requirement is for the hidden network, then we can set the scan type as passive scan, because active scan is not useful for the hidden network, which means that the networks that do not broadcast their SSID. Okay, so there are 2 types of scanning: active scanning, passive scanning. So here the radios perform both types of scanning on all of the channels allowed by the country of the operation. So while both types of scanning are available by default, active scanning is performed only by those channels that are allowed to transmit by regional governmental regulations. So channels that are not authorized for unlicensed use are excluded from the active scanning. Then we have passive scanning. So in passive scanning, the WLAN station moves to each channel as per the channel list and it will be waiting for the beacon frames. So beacon frames are used by the APs and of course stations in the independent basic service set to communicate or maybe to announce themselves. So the access point will be trying to send the beacon at defined interval. That is called target beacon transmission time. So here the access points are just like any other wireless device in the cell. They cannot send if the network is busy. Okay. So when the time comes for the access point to send a beacon and the network maybe is busy, so the access point will be delaying its beacon transmission until it is going to gain access to the media. So in IEEE 802.11 standard, the network is busy or not can be checked by using the carrier sense multiple access collision avoidance protocol. So we'll have the description of the mandatory field of the beacon frame. So in carrier sense multiple access collision avoidance, when the frame is ready, the transmitting device check whether the channel is idle or busy in order to avoid the collision. So maybe if the channel is busy means the transmitting device will wait for the random duration and again it is going to check whether the channel is idle or not. So if the channel is idle means it will send, which means it's free. You can send the frame. Okay. So this is the thing. Okay. Bytes. So here you will be having timestamp, beacon interval, capability information, SSID, supported rate. Okay. So these are all like mandatory. Okay. 8 bits, 2 bits, 2 bits, variable. Then you have distribution system parameter set. Okay. So you have CF parameter set, IBSS, independent basic service set parameter set, and you will have TIM mode as well. So everything, this one all optional, this one mandatory. So here you will be having timestamp. So after receiving the beacon frame, all the stations will be updating the local clock with their timestamp. So that helps in the synchronization procedure. Then we have beacon interval. So it is going to represent the time number of the time unit TU between the target beacon transmission time. So default value is set as 100 TU. Okay. So that is the time unit, 100 time unit. That is approximately 102.4 milliseconds. Then capability information. So that will be containing information about the capability of the device or capability of the network. Okay. Then you have SSID, service set identifier. So we'll have supported rates as well. So we'll have the information about the supported data rate by the corresponding access point. So this information is not used by the potential client during this passive scanning, but also by the clients that are already associated by the basic service set. So passive scan generally will be taking more time because the client must listen and wait for the beacon versus the actively probing in order to find the access point. Okay. So another limitation with the passive scan is that if the client does not wait for long enough on the particular channel, so client might miss a access point beacon. Okay. So as you know, then active scan. So discovering the network by scanning all the possible channels and of course listening to the beacons is not considered to be very efficient. So in order to enhance this discovery process, stations often use active scanning. Okay. So in the active scanning mode, the stations will go through each channel in turn, but instead of passive listening, okay, to the signals from access point, stations will be sending a probe request management frame that will be identifying whether the network is available on this channel or not. So directly it will be sending a request management frame. Okay. So maybe if any access point or maybe active station in the independent basic service set is presenting that frequency, then immediately they will be answering with the probe response frame. So request we send, response we get. Response we get means okay, good. So here we'll have passive scanning station, access point 1, access point 2. So beacon, then access point 2 beacon. Okay. Active scanning, probe request you see, access point 1 and access point 2. Probe response you get means okay, connection. Okay. So once a probe request is sent by the emitting station, it will be starting a probe timer countdown. It will go on. Okay. And will be waiting for the answers. If answer is not received means connection you. Okay. So this probe timer value is usually a lot shorter than the beacon interval. So common values will be like 10 millisecond reach. So at the end of the timer, the station will be processing the answer that it has received. No answer means station will go to the next channel on maybe a different frequency and the same discovery process is repeated. So the purpose of the probe request is typically in order to identify, to discover the access point and their supported networks, maybe like SSIDs or maybe BSSID. So here we'll be having the frame control, duration, okay, destination address, source address, basic service set ID. You'll have sequential, okay, so you'll have SSID. So these are all like MAC header. This is the frame body, okay, SSID, supported rate, extended support rate, and the forward channel FCS as well. Okay, so this frame contains two fields, SSID and of course the rate supported by the mobile station. So stations that receive this probe request use the information in order to determine whether the request station can actually join that particular network. Okay, so the probe response, the response frame field are very similar to the beacon frame field that enable mobile station to match the parameters and of course join the network. Okay, then authentication, everything you verified, connection, okay, authentication, okay, two-layer authentication. So after having performed a network discovery through the probe request or maybe probe response exchange, or maybe by listening to the beacons, the station wanting to join the network goes through the authentication process, so exchanging frames with the access point. So on reception of the authentication frame, access point will be sending acknowledgement, then authentication response. So the initial purpose of the authentication frame is to validate what device you are using. In other words, it is going to verify that the requesting station has proper 802.11 capabilities in order to join that particular network. Only then you can start it. So information related to the capabilities are exchanged between the station and the access point using the authentication request. So the client station, okay, authentication request, authentication response you are getting, then association request, then associated response from the access point. Okay, so if the request is accepted, means access point will be sending success in the response. Okay, then you have shared key authentication. So here in IEEE 802.11 1997 standard we discussed in the last class, so that include a WEP, shared key exchange authentication mechanism called as the shared key. Okay, so this shared key exchange will be adding two more frames to the default open system authentication that will have a 4-frame exchange. So this method you can call it as a shared key authentication that will be requiring the use of wired equivalent privacy, WEP encryption, and it's not widely used, not widely recommended. So first phase of authentication is described above, but when WPA or maybe WPA2, even in the mobile you can see that WAP type, WPA type, okay, or WPA2 type is used when the second phase of the authentication, four-way handshaking process takes place after the device gets associated. So in the authentication frame we see here, okay, frame control, duration, destination address, source address, BSSID, sequential. This is all MAC header, and this is the frame body. Okay, authentication algorithm number, authentication transaction sequential number, status code, challenge text, and the FC forward. Okay, so MAC header, this is the frame body. So in this authentication frame will be having authentication algorithm number. It is set for 0 for the open system and 1 for the shared key. And authentication transaction sequence number, it is going to indicate the current state of the progress. Then status code, 0 success, 1 means failure, unspecified failure. Then we have challenge text. Okay, so that is used with the shared key authentication frame. Then association. Okay, so if the IEEE 802.11 authentication frame completes with a success result, so station moves to the association. Connection has been established, then we move to association. So the purpose of this exchange is for the station to join the network and of course obtain the association ID. Then association request. So the first frame sent in the association phase is from requesting station to the access point or maybe to the station in the independent basic service set. So this frame is the association request frame, and response of this frame is association response frame. So the association request is unique as management frame and it is always acknowledged. Okay, so here you will see the MAC header, frame control, duration, destination, source, BSS ID, sequential. Okay, so 2266662. These are nothing but the bits, total bits that it will consume. Then capability information, listen interval, SSID, okay, service set identifier, supported rates, FCS. So this is the frame body. Then finally association response. So once the association request is acknowledged, the access point it is going to examine each field of the request and it will be verifying all the match. It's the 802.11 parameters. So in the case of maybe the parameter mismatch, AP will be checking whether the difference is a blocking or not, and based on that the access point will be sending the authentication response. So if the parameter difference is blocking means, then the response with the status code 1 will be sent in order to reject the association. Maybe in the case of non-blocking difference or maybe no difference in the parameters, response with the status code of 0, which means success, and the access point one parameter will be sent to the requesting station. So station must be compatible with the access point capability, otherwise it will drop the association process and it will start looking for the other access point. So here you see frame control, duration, destination, source, basic service set ID, sequential, MAC header. So this is the frame body you will see. Here you will see FCS with the 4. Okay. So here we see the functions association request and association response.